Right, ABCD is a parallelogram. And the thing about parallelograms is, let's say that angle is going to be equal to that angle. And this angle is going to be equal to that angle. And when I add these four angles together, I'm going to get 360. As well as that, we've got a circle of center O. That's the center of the circle. So here's another fact about circles. So if you look up here, looking up, that is a diameter because that is O. That's the center of the circle. So a line running through. So if you draw a triangle whose base is the diameter, if I draw a triangle, then these three angles add up to 180. It's a right angle triangle. Right, so that straight away is 90 degrees, that one there. So 90 and 37 is 127, and take that away from 180 is 53. So that angle is 53, and you can do the same on the other side. Well, this is going to be, again, that's a semicircle. That is the diameter, and if you draw a triangle inside a semicircle, one side is the diameter, that's going to be 90 degrees.
And that's going to be 52 down below.
Well, now watch, we'll follow this line here is parallel to this line. So you see that Z shape?
Yeah.
Right, so this angle here, 37, is equal to this one.
Yeah, that's 27.
Yeah. And then oppositely, yeah, 53. This one is 53. Right, so from there, after filling in all the values, you can write down, we can find the answer to the question. Write down angle BCD. So BCD, 90 degrees. Calculate DB.
It's 15.
DB, well, A. Alright, so I just have to see the measurements that we have here. Right, so AB was 12, BC, where's BC is 9.
Sorry, how did you get 90 there?
How did I get 90?
Yeah.
Of the angle around the C's.
Alright, so we're looking for the angle BCD. There's BCD. The angle BCD, right, what's the middle? The middle letter is C. It's the same as writing the angle C. What's the angle C? This one here.
Also, it's just a big C though.
Yeah.
So,
Alright. If you draw a triangle inside a semicircle, like that, the angle that it touches the circle is 90 degrees.
You just that one
Yeah. That was the question. What was BCD? What's the angle C? It's 90. Calculate DB now. So DB is going across here. Right, so if I was to redraw that, just from here, so you can see it clearly. Right, that's 12. That's a right angle. This side is 9, so this side is 9 as well. So that's 9. So we're looking for DB. We're looking for the diameter, or we're also looking for the hypotenuse. So we'll use Pythagoras theorem. So we'll square this. 9 by 9, 81. We'll make a square out of this. 12 by 12, 144. If I add these two squares, it's equal to the area of this square up here.
125.
125, or 225. 225 if I add those two, and then I get the square root of 225. So the area of that big square is 225. Get the square root, which is 15. So the hypotenuse is equal to 15. 225. All right. So 9. See, the length of that side is 9. The length of this side is, see, this is the length of the side that we're looking for. We have this, which is 12. Now we have this side, which is 9. I know this is 9 because this opposite side is 9 as well. Name the two isosceles triangles.
DC.
So DC, so we have, if you look here, there's an isosceles triangle. See that? The two radius, the radius and the radius are the same. So DOC or DCO. So a triangle DCO. So there's one there, isosceles triangle. And there's another one opposite, AOB. It's another isosceles triangle. There's another one. This one here, DOA is another one. And COB is another one. Right, next one. Find the angle BOC. So B, O, and C.
No,
Alright.
you skipped them there, C. In two isosceles triangles.
Just did it.
Oh, Jesus, man.
Find BOC. BOC. I'll just draw out this part of the triangle here.
It's 90 take away.
Alright, so that was 9. And I do know the diameter, the full distance across there is 15. Alright, so what's half that distance? Give me the radius.
That'll be 7.5.
7.5. And this is a radius as well. 7.5. What else do I know? Right, so this is an isosceles triangle. This triangle here. This is 7.5 and this is 7.5. So I'm looking for the angle, sorry, BOC. BOC. Well, this angle here is 53, isn't it? And because it's isosceles, that's 53.
53 as well.
Yeah, so 53 as well. So I add 53 and 53 and take it away from 180. So that one's 53. That one's 53 because it's an isosceles triangle. So I add 53 plus 53, and it's 106. And then to find the third angle, I take that away from 180. 74. So that one is 74 degrees. So BOC. This one here is 74.
How did you know that C was 53? There you go.
Yeah, I knew that C was 53 because if I look at, turn this around, this is an isosceles triangle. Isosceles triangle, it means the two angles are the same. Well, these two lines are the same. That means these two angles are the same.
Oh, so.
Alright. Find the area.
74 it is.
74. Find the area of the triangle ABD. ABD. Right. There's an easy way of doing this. Triangles are right. What I'm going to do first is I'm going to find the area of the full parallelogram. So it's 9 by 12, isn't it? 9 12s?
108.
18, yeah, 108. And what can you tell me about this line? What does it do?
Take it away from you.
That's A, B, D. I'm trying to find the area of this one. Yeah, just half it. So 108 is the area of the full thing. A triangle is just half the area of a rectangle. 54
square units.
square units.